Hello everyone. In this session, we will introduce dependent sources in PSpice at AA. First, let us go through the common types of dependent sources. The first one is VCVS. Voltage-controlled voltage source. It provides voltage gain controlled by an input voltage. And is a dimensionless quantity. The second one is CCS. Current-controlled current source. It refers to current gain control and is also a dimensionless quantity. The third one is VCS. Voltage-controlled current source. In electronics, it represents transconductance, and its unit is S, Siemens. The last one is CCVS. Current-controlled voltage source. In electronics, it represents transresistance, and its unit is ohms. The symbols for these four sources are located in the Analog.olb library file, in the right panel of the software. Select the shortcut for placing parts. In the Place Part window, select the Add Library button in the PSpice folder. Find and open the Analog.olb library file. In the Parts browser, you can find the corresponding symbols E, F, G, H. These four symbols are commonly used ideal dependent sources. The segment from 225 to 238 can be removed. Please open the corresponding project or pause the video to draw the schematic as shown in the example. Analysis of the example project. In the example, V1 is the stimulus signal source. E1 and F1 are the voltage-controlled voltage sources. And current-controlled current source. Their gain is determined by the param-parameter ratio. R4 and R5 are isolation resistors from the primary and secondary nodes to ground. They are often used in transformer simulations to avoid floating ground issues during simulation. R6 is used as a simulated load. In this example, E1 is set to an amplification factor of 2. And F1 is also set to an amplification factor of 2. R2 represents a series of resistance on the signal line. R1 and R3 represent the equivalent resistances of the primary and secondary sides of the signal. Next, we will use transient simulation to observe its characteristics. Create a new simulation profile and modify the settings. Run to time, 10 ms. Maximum step size, 5 us. After completing the settings, click the Run PSpice icon in the menu bar. For details, please refer to the demonstration in the example. by observing the simulation waveforms in SpiceAD. The green waveform represents the input signal, and the red waveform represents the output signal. The waveform is amplified by a factor of 2. We can see that the peak-to-peak voltage Vp changes. From 3 volts to 6 volts for the positive peak Vp+, and from -1 volt to -2 volt for the negative peak Vp. This means the signal voltage is doubled. It should also be noted that the DC offset VOF is also amplified synchronously in this simulation, with the amplification based on the 2 volts level. Please observe the red sine wave signal carefully. If you found this video helpful, smash that like button and don't forget to subscribe for more tutorials. Thanks for watching, and see you in the next video.